Okay, for these problems, let's look at this. We have a thiol. Sodium hydroxide, remember that's a strong enough base that it'll deprotonate this and make this into an excellent nucleophile. And it's non-basic, so it will do SN2 on this secondary bromide. So let's go ahead and copy these over. This is going to be my nucleophile. This proton is removed by the sodium hydroxide. It does SN2 on this carbon right here. And so the sulfur ends up being attached where the bromine was. Oops. Let's try that again. And put this, flip it, and put this right there. And that ends up being your product. The name of this is what? This is going to be 2-propane thiol. And what is the name of the product? Well, this is a sulfide. So, sulfide, and the two substituents on it, the two alkyl groups on it, are isopropyl and cyclopentyl. So we put those in alphabetical order. So it will be cyclopentyl and then isopropyl sulfide. There we go. Ooh, that looks messy, but you got it. Okay, next we're going to look at this. Here we have a primary carbon that's actually this phenyl group, makes it even a better substrate for SN2 or SN1. And we have methane thiol. What will happen? The methane thiol is a good nucleophile, and it will substitute to an SN2 on this carbon over here. I'm going to move the sulfur over to right here, and the methyl attached to it. Notice you have to make sure that you get the right atom having done the nucleophilic attack. The sulfur is the nucleophilic atom. Okay, I took the methane thiol away, didn't I? But you know what I'm done here. Okay, we have an ether here, and we have sodium hydride. What do we need as a reagent beforehand? Sodium hydride is a base that will deprotonate alcohols, and alcohols can form ethers, especially cyclic ethers, by doing an SN2. So let's see what alcohol we could have had. The best alcohol would be where this is part of the hydroxyl attached to this carbon, and that's a primary carbon. It would go fastest. So let's go ahead and see how many carbons we have here. 1, 2, 3, 4, 5, 6. So we're going to put those down. 1, let's make this a little darker. Okay, 2, 3, 4, 5, and then 6. So those are my carbons. Let's go ahead and put an oxygen on there. That oxygen is going to be right here. Let's make this about. Oh, that's too big. Let's make it 12. Okay, so let's put that oxygen here. Still pretty big, but you can read it. Okay, that is the oxygen right here. And let's put a hydrogen there also. Okay, next we have to have a leaving group on this carbon where the SN2 reaction occurred. So there has to be a leaving group right there. What's a good leaving group? Let's go ahead and put bromine. There we go. That will work. All right, let's go ahead and look at this alkene making this ether. What you have seen so far in chapter 18 is that to make ethers from alkenes, you do something called alkoxymercuration. What are the reagents for that? The reagents are going to be mercury. Let's make this smaller. Okay, a mercury acetate compound is slightly different than what you've used before. It's a little bit more aggressive. Okay, O. Okay, and we're going to put like that, A2. Okay, so this is your acetate, and we're going to put 3 here, and we're going to put another parentheses. So here's the parentheses, and then a subscript 2. And a subscript 2. All right, that's number 1. What's going to be number 2? The number, with that, you're also going to have the alcohol. What alcohol do you have to have? Notice, let's look at where these carbons came from. Okay, if I look at this thing here, okay, these 3 carbons right here, oops, I'm trying to move it over so it's a little cleaner. Okay, these 3 carbons right here are these 3 carbons here. Then we have these 2 carbons, that's those 2. And then these 2 carbons are right here. So I need an alcohol with 2 carbons. We're going to need ethanol in there. So we can put ETOH. All right, let's go ahead now. And then what do we follow with? Mercury is an oxidizing agent, so we're going to follow with a reducing agent, sodium borohydride. Okay, and that is going to be, we have an oxidizing agent followed by a reducing agent, and it gives us no net increase in oxidation. Okay, let's look at these things here. How is it we can go from a ketone to this alcohol? Hopefully you remember that you need a Grignard reagent. That methyl magnesium bromide is what it's called. Okay, and so we need a 3 down here. And then magnesium bromide. Ooh. And let's go ahead and get it stuck up there where it should be. Okay, so methyl magnesium bromide followed by a little bit of acid and water. And that would give us this alcohol. How do we go from here to here? Well, you really could use phosphorus oxychloride. Because it's a tertiary alcohol, you can use concentrated sulfuric acid. Phosphorus oxychloride works pretty well for pretty much anything. So we can say phosphorus oxychloride, a dehydrating agent. Over here, what can we use? Well, let's use a peroxy acid. So RCO, and we're going to have, it's going to be an acid, but remember this is with 3 oxygens in there, an extra oxygen. To go from here down to there, we have to turn this into a good nucleophile by first removing that proton. And we can use a lot of things for that. Sodium hydride works well. And what would be the second thing that we need? We would need something like methyl magnesium bromide in order to That's really an offset compound, isn't it? Okay, let's get this one set up there a little better. Okay. Now, to go from the epoxide down to here, that's just cleavage with acid. And you get a transdiol. Okay, and that's it.